Hello guys, thank you very much for being with me today. So our today's topic is Docker images. When you hear about Docker, the first thing that comes to mind, or the first things that you actually read on the internet when you look up the definition, is Docker containers or containerization. So as soon as you're okay with the containerization definition, you come across Docker images, and this must be something new and even confusing, because you can be like, okay, I know what Docker containers are, what Docker container is, but what actually a Docker image? Is it something different? Is it a container? Why do I need a Docker image? And also maybe you've watched my video about 5 key facts about Docker, link to which should appear up here or up there. You can question actually if the Docker is based on my host operating system, so I don't need a hypervisor to have a Docker. Why would I need an image? So why would I need a specific image to compile my application and run a container? In this video, I'm going to provide an explanation for that and show you some hands-on how to pull images, how to use them, how to use specific tagged images, and how images actually fit within the understanding of the Docker as a technical definition. So to start with, in order to compile a specific application, as a DevOps engineer or anyone else who needs to do that, you would need a specific image, a specific container that has some pre-installed features, pre-installed environment, and that is called Docker image. So for example, image can have a pre-installed software along with an operating system. That would be, for example, Nginx image that you can see on my screen, or the image with pre-installed Python, the image with Redis, or image that is good to work with Postgres databases. Or it can be a Ubuntu image that has the operating system on it and nothing else. Basically, it's the flavor of Linux, but you don't have any specific software installed on it. So there is a wide range of images available. The first go-to point for Docker images is Docker Hub, since Docker Hub contains official Docker images that you can use. But obviously, while some companies use publicly available images, other companies have their private registry. What Docker Hub is, it's basically a public registry of images. Think of it as of a library where you can go and take a book that you'd like, the book being image in this case. So you don't have to sort of pre-prepare the container, pre-deploy it with a specific OS, with Python installed and etc. You can just take the image and deploy it and then use the container for your application right away. As I said, your organization can have a private registry, or you as an individual can have a private registry. You can simply register with Docker and create your own repository and build images and containers from there. But many users still go with Docker Hub since it contains most of the necessary images that you might need for your application. There are 10,000 available results, so the chances are that you're gonna find the image that you're looking for among the images available on Docker Hub. Well, whenever you deploy an image, let's see. If you run Docker images, you can see the list all of the images available on your machine. The list of images available on mine includes Ubuntu and Nginx, the latest versions. So you may see that the first column shows the repository name or image name. The second column shows the tag. The third column is an image ID. It's a sort of the string that identifies that specific image, when it was created, and then the size of the image. So the most important points of information that we need to get from this output is the repository and the tag. What tag means? So in order to explain it in simpler terms, when you haven't worked with tagging before, with version controls and etc., tag allows you to choose the specific type of image that you might need. And you might think that I've got Ubuntu image and I just need Ubuntu. Why would I need any other image, or why would I need tagging? Imagine that you want an iPhone. And whenever you say you want an iPhone, usually by default, you mean the latest iPhone. And the same is with tagging. So if you just try to pull meaning download on your machine, on your Docker repository, the image, and you run docker pull Ubuntu, as you may see on the screen, it understands that you need the latest image. And by default, you're being provided with the latest Ubuntu image available. But in some cases, you might need the image that is not the latest. You might need, for example, iPhone 11th, iPhone 10th, and that's where tagging comes up. So if you tag the image while pulling it, you will pull a specific image, which might not be the latest. So for example, supported tags for this image are the versions of the Ubuntu. If you have a better understanding of the Linux flavors, you might see that these are the version numbers of the Ubuntu Linux operating system. Just to show you how tagging works, I'm gonna go ahead and try to pull Ubuntu 16.04 version. So to do that, I'm gonna type in docker pull Ubuntu, just the same as provided on the website, and then I'm gonna add semicolon and 1604. And that is going to allow me to to actually pull specific version of the Ubuntu image that is available. And if I run Docker images now, you may see that now I've got two Ubuntu images, one of which is 16.04 and another one is the latest. We can do that same thing on any other image. Let's go ahead and try Python. For example, if I run docker pull Python, it's using the default tag, if you may see. So anywhere where you don't mention the tagging, the version of the image that you want to get, the tag, it uses the latest tag. So if I would run docker pull python semicolon latest, it would be the same as would running it without any tagging at all. Now it's done. We've downloaded the Python image. So if we go ahead and list the images, you might see that I've got the Python latest image available on my machine. Now if I scroll down to the Python image on in Docker Hub, you can see that there are a number of tags available for the Python, depending on what specific image of Python or what specific packages or pre-installed libraries of it you need. So if I go ahead and use this tag, just pointing actually, and try to download it with this specific tag. So I copied the tag from the Docker Hub from the list of supported tags, and you might see that it's downloading this specific type of Python images, and it means that it has some booster or any other types of libraries that meet this tag name. I'm gonna speed it up and meet with you when it's downloaded. Now if I go ahead and run Docker images again, you may see that I've got two Python images available, one latest and the second one, the ones that we've downloaded just now, we pulled just now, if we use the correct Docker terminology. So now when we've got the images ready, you might say that, okay, now I can go ahead and run a specific image to start compiling the application. Why not? Let's do that. So if we go ahead and do docker run Ubuntu, it returned, and if we check docker ps, so docker ps command helps us to check the running containers at the moment that we can create from images, and it shows us that there is no container running at the moment, which is very strange. So if we go ahead and actually try to get information about all the containers with all statuses, even if it's not running at the moment, it will show us the containers that exited a short while ago. You may see that the Ubuntu container was created 36 seconds ago and it exited 35 seconds ago. And why do you think is that? Well, actually, because the way Docker works, and one of the things that makes it different from the virtual machines, it runs containers only if there is a specific program running in them. Docker is not designed to run a container where there is no program, to run a static container sort of. Well, because when you deploy the Ubuntu, there is no specific application running within the Ubuntu. So Ubuntu is just an image with an operating system, and that's it. There is nothing else that comes with it. That's why Docker starts running Ubuntu image as it shows, it started running it was created, and then it exits a second later because there is no available programs that runs within Ubuntu. What we're gonna do to check if what I've said is true or not, we're gonna pass a specific program to the Ubuntu image. So what we can do here is that we can run the Ubuntu image in an interactive mode with a terminal. These are the explanations of the flags that I'm currently using, and indicate the name of the image, and then indicate the program that I wanted to run, and it's gonna be bash. So you might see that the container was created, and the program that it's running is bash. Bash is actually the shell that Linux uses. There are other shells available, but it is one of the most common shells. And currently I am in the shell, and I am in the interactive mode, which allows me to pass the command to the shell, and my container is attached to my terminal sessions that I'm currently using. So this means that I can pass several programs, different commands to the terminal, to the container from my terminal. It can be as simple as ls or who am I. The commands that I'm running are basic Linux commands, so there is nothing too complex to it, but I'm just running them to show you that I'm currently in the running container that was created from the Ubuntu image, and I do exit, and I exited it. If we run docker ps now, wow, it's hard to type when someone is watching you, yeah? Let's go ahead and run docker ps. There is no container running because I exited the previous container. And if I run docker ps -a, you may see that it was created around a minute ago. I ran some commands and then it exited 21 seconds ago after I exited the session, the running program. Another very simple example would be to create a Ubuntu container and pass a simple sleep command to it. Docker run Ubuntu sleep, and I want it to be created to sleep for 5 minutes and exit. 1, 2, 3, 4, 5. Perfect. So if I run docker ps, there is no active container running at the moment, and if I run docker ps -a, you may see that the program that was within it was sleep 5. It was created 15 seconds ago and exited 9 seconds ago. So basically, the point of me showing it to you is that the image should contain a specific program within it for the container to start running and to run successfully. When you run an image that doesn't contain any program within it, no other application other than the operating system itself, it's gonna start, but it's gonna exit immediately. So in order for the Docker container to run, you have to pass a program to it. So you might see that Docker containers are more lightweight because when you sort of deploy a virtual machine, you might see that the Docker containers are quite lightweight because when you deploy a virtual machine, it's there. Whenever you turn it on, it's there, whether you're running application within it or not. You just can put a wonderful, nice background to a virtual machine and just look at it, and that's it. But that's not how it works with Docker containers. Docker container has to have an application or a program to run in order to live, in order to exist. Otherwise, it just exits and quits. So as you may see, containers don't like loitering around. They like to do something in order to be useful for the Docker community. Another command that I want to show you is actually how to clean up the images that you've pulled, because they obviously take some space and you might want to clean them up from time to time. I mean the images that you're not using. So if I go ahead and run docker images for the images that I currently have, the command that you have to use to delete images is docker rmi. There are two commands available actually. One of them is docker rm, which is for containers, and the second one, let me show you. So this command is docker rm, and here you would put container id in order to delete a specific container. The command that should be used for the images is docker rmi, where I stands for images, which is a very good and intuitive way to remember it actually. Docker remove image, and that's it. So I'm gonna go ahead and try to delete my Ubuntu older versions that I've downloaded using the tag. Remember that if you download the Ubuntu just using the Ubuntu keyword, it's gonna go ahead and download the latest Ubuntu available, because by default the Docker is using the latest tag for the images. So first of all, it untagged it. It also untagged it from the hash. So the Docker is using SHA-256 hashing method in order to hash containers and just check if they were tampered with or not. But we're not going into the depths of cryptography here. So just the fact that this container has been deleted works fine. If you want to do a trick and actually delete all images at once, you can do that by putting one command into another on the command line. So if I go ahead and put in docker images -q being the quiet mode where you don't see the information in a tabular form, you just see the names of the images available. You can see that, sorry, not the names, but image IDs available. You can see that these are the image IDs available at the moment. And if you go ahead and run docker rmi, and instead of putting the image name, you can instead put in the command docker images -q. So what this command would do is that as an argument to the docker rmi command, it will pass the image IDs of the available images, and recursively it will delete all of the images available on your machine. I'm not gonna do that at the moment because I don't want to lose all of the images available on my machine, but if you wish to get rid of all of the images on your machine, please go ahead and do so. So further information about Docker image related commands you can get from Docker documentation. That is very wide and actually helpful. So for the Docker CLI, you can look up the commands that I have used here from the Docker documentation available, and you can obviously look up even more commands to go in depth of image management on the Docker. Alternatively, you can actually use a terminal to look up the information instead of going to the browser. For example, if you type in docker rmi --help, you're going to get information available in the documentation with less examples. Obviously, the documentation page on the browser usually has more examples that comes with it. For example, you see here are the examples, how it works, how you can make the command more effective. But here it's just the very short and precise information. But again, it's very easy and fast to get it. The same is for other command like docker images --help, and that's how we get the different available flags of the docker images command. Thank you very much for being with me today, and see you in the next video. Have a nice day. Bye.